hydroxide. So water, and this is weird. We have learned that things can decompose into their elements, but now we're talking about things decomposing into ions. Water is covalent. This is strange. Water should not be breaking apart into ions. It's not ionically bonded. It's covalent. So there are some weirdness here, and that's what acids are. They're a little bit weird. They're covalently bonded, and they dissociate into H pluses. Now we can say water is an acid. You know why? It gives off an H plus. We'll talk about it. You can also say water is a base because it affects the hydroxide concentration. So water can do both. Now, water naturally breaks apart into ions. It's called autoionization. And we know that if we were to measure the concentration, this box, this bracket, represents molarity. So if I measure the exact amount of H pluses and the hydroxides, I know I come up with a number that's 1 times 10 to the negative 14 always. Okay, that's an equilibrium constant that stays constant. So you learn. Now we also learned that water can be broken apart by colliding with another water. It's another way to think about it. And what happens is one water donates an H plus, which we learned is a proton. And the one that accepted that proton now is positive, so H3O plus. And the one that lost an H plus becomes a hydroxide. So whether we talk about the H plus ion concentration, aka proton, or the hydronium ion, we mean the same thing. We learned yesterday that acids increase this concentration. But we first learned that if I have pure water, as I do right here, pure water, okay? If I have pure water, and I have no acids or base being added, what's the pH in here? We learn that the pure water with no acid and bases being added should be 7. Now why? Well, if one of these breaks apart into one of these and one of these, then it should make sense that these guys are equal. So we learn that, yes? Piece of paper, sure. Would you?
I knew you were going to hear me.
I was. Okay. Now we learned that this number has to be the same. Why? Because it's a 1-to-1 ratio. So my friends in chemistry, this number, when multiplied by itself to equal 1 times 10 to the negative 14, has to be 1 times 10 to the negative 7. And we learned that the other one is 1 times 10 to the negative 7. Because when you multiply exponents, you add them. It's negative 7 plus 7 is negative 14. I can't say this enough. They'll always equal this number. This is a constant. Now, what did we learn yesterday? Well, we want to measure this concentration, and it's sometimes very bulky to deal with this number. So we found a system where we can look at the concentration swings of H plus. And look at this. Look at this right here. This is how H plus can change. It can go from 10 to the negative 1 or 1 all the way to 10 to negative 14. It's a huge swing. This is 14 zeros difference. This is a 1 molar solution. This is 1 times 10 to the negative 14 molar solution. 0.00, 13 zeros in front. It's a huge swing that this can be depending upon if I'm adding acid or bases to my water. So to minimize all of these numbers, what we do is we take and stuff the exponent, take the exponent base 10 and make that the number that represents it. So we take this entire number and we stuff it into an exponent. And we call that making a p. Now little p means what? Negative log. Negative log of the h. So what we do is we take the positive value of this negative exponent. The log of this number is 7. Actually, it's negative 7. By putting a negative log, it becomes 7. So all you have to know, party people, is that we're taking the positive value of that negative exponent. And that makes it a pH of 7. And as we learned, the negative log of this, it's all about the H. If I want the OH, okay, it's not all about the base, as the song goes. It's all about the H. Okay? Because if it was all about the base, it'd be POH. But they want pH, so it's about this, guys. The base. Now, if pH is 7, that means that these guys have to be equal because when multiplied together, you get that. Look, pH is 7, we learned is neutral. Equal amount of H pluses is hydroxides. Now, this is important. If I increase my H plus or my H3O plus concentration, let's increase it 100 times. Let's be crazy and increase it 100 times. If I increase this 100 times, I make it 100 times more acidic. Acids give off H pluses or produce this or make hydronium ions. If I increase this 100 times, what's my number? 1 times 10 to the negative 5. I've just increased it 100 times. Isn't 100 10 to the 2 base 10? 2 zeros? So this times that 2 plus 7 is negative 5, right? That's what it's doing here. This is getting bigger by 2 zeros. What's the pH now? What's the pH now? What's the positive value of the negative exponent? 5. What's the hydroxide concentration? 5 plus what is 14? 1 times 10 to the negative 9. It's that simple. It always equals 10 to the negative 14. And look, when the pH is 5, who's got a bigger amount? H plus or hydroxide? H plus. When the pH is 5, the H plus or the H3O plus is bigger than the hydroxide. So as the pH drops from 5 to 4 to 3 to 2 to 1, the H plus ion concentration increases and the hydroxide drops. Okay, it's important you get that. As the number of pH gets smaller, that means the negative exponent is getting smaller, but that really means this value is getting bigger. Okay? Now, in a basic pH, you got more hydroxide, and that's bigger than 7. Remember, if I made this number equal to 1 times 10, let's increase the basicity now. Let's be crazy and change the ink to magenta. Now, if I increase this number, let's say 1,000 times. So increase the basicity 1,000 times, it's 1 times 10 to the what? I'm going to increase the basicity. It's 10 to the 3, right? So this would be 1 times 10 to the negative, increasing this 1,000 times. 1 times 10 to the negative 4. Right? It's getting bigger by 3 zeros. 1 times 10 to the negative 4. My friends in chemistry, what's the pH now? Is the pH 4? This is my hydroxide concentration. It's all about, no, it's not all about that base. It's all about the what? The H. So what's the H? If the hydroxide is 1 times 10 to the negative 14, the H plus or the H3O plus, they're synonymous. Yeah, 4 plus what is 14? Right, negative 10. What's my pH? pH is 10. Which means what? When it's above 7, I've got more hydroxide. So that's what you have to know. Bases somehow increase this concentration. Acids. Why do we care so much about this swing? Because life is delicate. And we live in an aqueous environment. And we have to take very, very care of what the pH is. My friends in chemistry, we breathe because of the pH imbalances in our blood. We have proprioceptors in different places in our bloodstream that measure the pH. When the pH drops, it triggers the autonomic nervous system to breathe. You cannot kill yourself by trying to hold your own breath. You can't. Your body will take over and force you to breathe because we have these receptors that measure pH. Now, I say, well, why does the pH drop? Why does our blood get acidic or basic? Acidic over time. Well, I'll teach you. CO2 in water makes the pH drop. We'll talk about that. And as the CO2 builds up in our bloodstream, it makes our blood become acidic. It drops the pH. Our proprioceptors see that or feel that, and it forces us to start breathing out the CO2, getting the CO2 out of our blood, which raises our pH. Ever see people that hyperventilate themselves in order to hold their breath longer? I remember being at a pool party and someone saying, who could swim to the end of the pool and back? And everyone like failed, and I was like, I was doing that for a minute, and I was able to go back and forth. Now, I was also, 6'9", so it didn't take much time to, jump, touch, and come back. But no, the whole point was I was able to hold my breath longer than the people I was competing against. And of course, they were young kids, because I just knew to hyperventilate by breathing out a lot. I'd be getting a lot of the CO2 out, and I would be raising my pH of my blood so high that it would take a while for it to drop and get acidic before my nervous system kicked in to force me to breathe. Yes?
So you know those videos of those people like going like, and then the friend like holds their chest or whatever, and they like seize out and they like pass out and they wake back up fine.
Yeah, you can pass. Yeah, you can definitely feign or by doing that. Yes, but that's.
I've seen like videos like of the people like going like that, and the friend holds their chest, and then they.
I'm not sure with the holding chest. Yeah, but if you do too much of that, okay, yeah, you can be lightheaded, and you certainly can faint. Absolutely. Okay, exchanging too much of the air coming out. Absolutely. All right. Any case. So these questions should be easy, but I'm going to go to a demonstration before I go to the worksheet. So let's go to this demonstration. You guys see it up here? I have pure water. So let's go to this worksheet, this demonstration. Okay, pure water. And hopefully my Lager Pro is still working. Okay, anyone see the pH? What's the pH? Okay, let's experiment. Okay, so here we go, maybe. Of course, it's not working. No device connected again. That happened yesterday. I had it all set up and it didn't work. All right, let's try this again. Let's see, set up sensors. Is it a green or is it red? Red. That's red? Okay, let's try this again. All right, set up the sensors. No interfaces. There's no GoPro. Okay, cool. Went green on me. Okay, let's go to pH probe. This just kills the class when you have to stop like this. That's all set up. Okay. Come on. Pressure, pH. Choose a sensor. pH. Okay, a lot. Okay. Yay. Maybe. We'll see. Okay, so there's my pH. It's about 7. And as I collect, you can see that I'm about pH of 7. Okay, now of course we know why it's about a pH of 7. Because I have pure water in there. So pure water breaks apart into an equal amount of H pluses and, of course, OH minuses. Now, it's not exactly 7 because I didn't quite calibrate. Well, I did calibrate. Now, I'm going to put in some acid. In fact, let's do some base. Okay, I'm going to put some base in. What's good? You can just leave that there. Okay, so I put some base in. And you can see what happened to the pH. It spiked a little bit. So what happened to my pH? It raised when I added a base. Why? What was I increasing? I was increasing the pH. Why? By adding what? What did I add to the container? I added a base. Now, I'll tell you what I added. I added NaOH. What does NaOH break apart into? It's soluble. Na plus and OH minus. This is a base. So I was dropping OH minuses into here. Now, what do we know? Well, it's the H plus times the hydroxide. By increasing this value, this one had to do what? This value was going up. This one had to go what if it has to equal 10 to the negative 14? Yes, it had to go down. All right? So this number had to get smaller. It started at 1 times 10 to the negative 7, but it got smaller. Well, what is it now? It's almost, okay, 11.7. Let's pretend it went to 12 to make things nice. If this went to a pH of 12, what's this concentration? If this went to 12, wouldn't it have gone to 1 times 10 to the negative 12? Isn't that the pH of 12? Yeah, it got real small. It got smaller because this one got what? If this one is 12, 12 plus what is 14? 2. Now it's 1 times 10 to the negative 2. This got bigger. And that's why the pH raised. Now, I'm going to add a chemical to watch this happen. I'm going to add something called a chemical indicator. I'm going to use something called phenolphthalein. Phenolphthalein turns color in the presence of acids and bases. So I'm going to add phenolphthalein. Okay, so it makes it nice, pretty compound. All right, now, pretty, I guess fuchsia, pink, I don't know. Now, I'm going to now add, start this again, I'm going to now add some acid to this. Okay, so it's 11.72. Now I'm going to drop some acid. This is the base. And I'm going to drop some acid. I'm going to increase the H plus ion concentration. What's going to happen? Whoa! What happened to my pH? It decreased. Add some more acid. Drop some acid here. What happened to my phenolphthalein? It went clear. Phenolphthalein turns pink in the presence of a basic solution that's what, above 7 or below 7? Above 7. But I could add more what? Base to bring back the color. So as I bring back, watch the color. You see it kind of disappearing? I'm pouring, you see the pink and it's disappearing. Why? Right. When I pour this, the base, the phenolphthalein sees the base, right? But then the acid neutralizes the base. It's called a titration. But eventually, I'm going to get to the basic range and it's going to stay pink. And I'm there, in a basic range. So indicators help us decide whether something is basic or neutral. Add some acid. What happens to my color? Show this to a peasant in the medieval times. And I'm a lord, I'm a wizard. And they make movies about me now, riding big brooms and going to wizard schools. Okay? Right? Having too much fun. Cool part is, why did it disappear? This is the really cool part. The reason why it disappears is the extra hydroxides I add are being tacked by the H pluses. It's called neutralization. What do you think H plus and a hydroxide make, OH minus? They make water. And the pH of water is 7. Okay? So that's the demonstration. All right, let's go to the worksheet. All right? To the worksheet, party people. All right, so number 1. Pneuma